Here's an interesting problem for us today. Palindromic Harshad numbers. Puppy Pete's bus journey had already gone wrong. The bus company sent a bus replacement. However, Pete was pleased to notice that the number of the bus was a palindrome, and that got him thinking about Harshad numbers. Don't know why that would be the case, but you know what Pete's like. A Harshad number is one which is divisible by the sum of the digits of the number. For example, 10 is Harshad, as 1 plus 0 is 1, which will divide is a factor of 10. 11 isn't Harshad, because 1 plus 1 is 2, which is not a factor of 11. So the problem today is, what is the first Harshad number less than 10,000, which is also a palindrome? So I'm going to click over into Python, into Jupyter Notebook as before, and I've already set up a misspelt, there you are, palindrome Harshad. So a couple of things to think about before we start coding is, well, what's a palindrome? So a palindrome is something that is the same forwards and backwards. So for example, as a word, ABBA is a palindrome because it reads the same forwards and backwards. And as a number, 121 is a palindrome because it's the same both ways. So we're dealing with numbers. So the first thing we need to think about really, or one of the way I'm going to approach this problem, is to think of a number and to check if the number itself is a palindrome, okay? And then just to print that number. And we could go from say 1 to 100 and print them out and see what they look like. So I'm going to make a function actually for a palindrome, okay? So my palindrome function, so let's call it isPal. And into isPal I'm going to pass it's going to be a variable, and I'm going to call it x, which is going to be a number. So the first thing I need to do is I need to create the reverse of the number. Now Python can't do that by default, just reversing a number, but we can reverse a string. So we can take characters, text characters, and reverse them. So the first thing I'm going to do is I'm going to define xs as x string, and I'm just going to say it's the string of x. So now what I need to do is I need to reverse xs. So I'm going to have xsr, which is xs reversed. And Python does that in quite an interesting way, a clever way. And I'll show you how that works. I am going to take x of s, or xs, and in square brackets, I'm going to say colon, colon, minus 1. So what that does is the colon, colon, minus 1, it starts at the end of the string and goes to the start of the string. So a default Python thing for reversing a string is colon, colon, minus 1. And it will, from the end of the string to the start of the string, work out the characters that fill in, that meet that criteria. So at this point, if I was to, just for the sake of it, print x of s and xsr, okay, and if I was to now call isPal, it doesn't work, it's not going to tell me if it is a palindrome, it's just going to print it. And if I print out isPal, I don't know, let's pick a number, 127. Let's see what happens if I isPal 127. I should get 127 and 721 returned. I do. 127, 721. So what that little function is doing is xsr is the reverse of xs. So what I can change that print statement now to is a conditional, an if, and I want to say if x of s exactly equals XSR. Okay. So if the forward version of the string is the same as the reverse version of the string, I am going to, in this case, I'm going to, let's just do print XS XSR. Okay. And now I'm going to do a little for loop for, I don't know, I in range 100. And I'm going to is pal of I. So I'm going to iterate from 0 to 99 and pass 0 to 99 into is pal. And every time the forward number equals the backwards number as a string, it should print out the result. So I guess I should get the numbers 0 to 9, because that's the same backwards and forwards, and then 11, and then what would be next? 22 maybe? Let's see what happens. There we go. 0, 0, they're the same backwards and forwards. And then we get to 11, and that's the same backwards and forwards. And that's boring, I suppose. So if I make that go up to 200 and run it, I should also now pick up 101, 111, 121, and so on. So we can see the palindrome function working backwards and forwards. If I scroll down, 101, 111, 121, 191. So there we go. I'm going to get rid of that now because we've got a function that clearly returns if it is a palindrome or not. So what I'm going to do here is if x of s does equal the x of return of x, I'm just going to return true. All right, that's what I need to do. So if I now was to print is pal 127, I should get false or get none. Okay, whereas if I is pal 121, I should get true. There we go. So is 121 a palindrome? Yes, it is true. So I've got a function there now that is returning is a check to see if a number is a palindrome. That's the first check. I can now make a different function, which is to consider the Harshad bit of it. And the Harshad bit of it says, a Harshad number is one which is divisible by the sum of the digits of the number. Okay, so I need to take a number and sum up the digits and then actually divide that to see if it will be a factor of the original number. So I'm now going to do define is Harshad. So is it a Harshad number of x? Okay. And to define if it's a Harshad number, the first thing I need to do is I need to sum up the variables, the digits. So I'm going to start then with a sum. Let's call it x sum. And I'm going to set it to 0. Every time we call this function, make sure that the sum is 0. Okay. So now I need to take the number and I need to iterate over all of the digits of the number. You can't iterate over the digits of a number. You can only do that in strings. So I need to do a bit of string manipulation. So in the same way, I've got x string previously. So this time I'm just going to put a temporary variable. I'm going to call it y for the sake of it. And y is going to be the string of x. Bit of redundant code going on here because it's the same as the previous one, but it doesn't matter. Y is the string of x. And now I'm going to go for I in y. So what that's going to do is for each of the elements of the string y, which is now the string representation of the number. So if the number is 127, it's going to start and go through 1, 2, and 7. Okay. For I in y, what I need to do is I'm going to say the sum, or in this case, x sum, and x sum, I'm going to add the value of x to x sum. X sum starts at 0, so I want to add all of the digits to it. But they're strings at the moment, so I'm going to do plus equals, which is how we add to the original string here, or the original sum here in Python. and I'm going to make the y back into an integer. So I'm going to take the string value of y, make it into an integer, and add it to x sum. And I'm going to iterate over all of those digits. So what that's done is it's created a variable called x sum. Now that's good. X sum is nice. So I've now added together 1, 2, 7. I've added 1 to the 2 to the 7, which gives me 10. So I now need to decide to try and work out, is the original number, or is that a factor of the original number? We've done this previously, which is this the remainder, the mod function. So I'm now going to issue a conditional. So if, and the number that we're iterating, x is the value of the number. So if x, and I'm going to divide it by x sum. So x% x sum takes the integer x and tries to divide it by this sum of all of the digits. If that is exactly equal to 0, okay, if it's exactly equal to 0, it's Harshad. We're returning true. So that will return true if this is now a Harshad number. So I've got two functions. So we know from our example over here that 10 is a Harshad. So if I just issue print is Harshad 10, I should get true as an answer to Harshad 10. Let's make sure I clear the outputs. If I run that now, it'll push 10 into this function and it'll go through everything. It should tell me it's true because I've worked that out previously. If I run this code now, okay, so that's not worked. Is Harshad 10? And it says none. So that's not worked. Why might that not have worked? For y in x string, I is I, it's enter j. If x sum is 0, return true, is Harshad, Harshad. Okay, that's interesting. So let's try and debug this. So x sum is 0. Every time this is Harshad called, it does that. Y is the string of x. For I in y, okay, right, so it's the integer y bit that's wrong here, isn't it? Because I is the integer that changes every time. So so for I in y, if it's 127, I is 1, I is 2, and I is 7. So here I need integer of y, because that will iterate through all of the characters, all of the digits in the number. So let's clear the output and see what happens. I'm expecting this to say true, and it does. So if I now change that to 11, it should now say none, because we know 11 is not a Harshad number, which it does. Brilliant. So let's clear the outputs. So I've got two functions, one that checks it's a palindrome and one that checks it's Harshad. What is the first Harshad number? Less than 10,000, which is also a palindrome. So I'm going to create a loop, and I'm going to go from I'm going to go less than 10,000. So I'm going to go I in range 10,000, which will go from 0 to 9,999. And I'm going to pass all of those numbers one at a time. I'm going to pass it into is Harshad and then is pal. So the first thing I'm going to do is I'm going to say if is Harshad I equals true. So it's going to pass 0 into Harshad. It's going to pass the numbers from 0 to 9,999 into that function, and it's checking to see if it is a Harshad number. If it is a Harshad number, okay, if it is a Harshad number, I also want to now check if is pal of I equals true. So if it's a Harshad number, and we now go on and check, is it a palindrome? It is a palindrome, okay. At that point, I could print it out, couldn't I? I could print it out. I could say print I. And what that will do is it will print out the number if it is in the range from 0 to 9,999, It's if it's Harshad and if it's a palindrome. Now I'm going to run that and we'll see a screen full of numbers, but we're going to come back and modify the code. We can get the answer here, but it probably won't look very great. So I'm going to run it. Oh, what have I now got? I've got division error. I've got integer modulo by 0. That's interesting. So it's chucking an error because the range 0 to 9,000, range 10,000 goes from 0 to 9,999. And here is Harshad. X sum, when we start at 0, the sum of the digits is 0. So we're going to be dividing by 0 here. So actually I want to force this range to start at 1, not at 0. I'm going to clear the outputs and run it again. And I'm anticipating a screen full of numbers. So these should all be palindromic numbers. 1, 2, 1, 1, 1, 1, 7, 1, 2, 2, 2, 2, 5, 2. And I could scroll through the list and I could find the biggest one here, which is 8448. So the answer to the question, 8448, is the largest palindromic Harshad number less than 10,000. But I've got a screen full of numbers. So actually, let's go back to the question. What is the first Harshad number less than 10,000? So instead of going from 1 and counting up to 10,000, which has forced me to do 9,999 calculations, I could start at 10,000, well actually less than 10,000. So if I start at 9,999 and go down to 1 in steps of -1. So I'm going to do the range the other way around. This time, if it's Harshad, if it's a palindrome, it's going to print it. And the very first time it prints something, I'm going to issue the break command, which will bring the code to a halt. So if I clear the outputs, and if I now run this code, I literally should just get 8448 as the answer. There we go. So the problem was deconstructed into two functions. The first function was working out whether or not something was a palindrome. The second function was working out whether or not it was a Harshad number. And then I wrapped that round into a for loop, calculating the instances where it was both Harshad and a palindrome. And then we returned the answer of 8448. So this has been 101 computational problems. This is with myself, Glenn Gilchrist, and this is problem number 3, Harshad numbers, palindromic Harshad numbers. Thanks for listening.